So it's also, I think, easy to ask for, and you should require this from people who implement AI on your behalf. What data was used to train the AI? Do you keep that data around? Can I examine that data to make sure it was representative of the real problem I'm trying to solve? Because one challenge we'll see, you might hear the term overfitting, which is I've trained an AI so well on my data set that it recognizes aspects of my training data that it thinks are relevant. The example here, a friend of mine is the CTO of the Nature Conservancy, and they ran a competition to detect illegal fishing. And the way this works is there's a camera on fishing boats that takes a picture of the deck, and they can see the fish on the deck. And so some of the people who were training the algorithms to identify that someone was doing illegal fishing, the algorithms were actually being activated by noticing certain boats collected certain illegal fish. So they weren't detecting the fish. They were saying, you know, that red boat, he's always catching the evil fish. And so he had the AI reflect back what it was learning about how to identify what the issue was. And the AI was saying, red boats are bad. And he's like, no, that's not going to generalize well, because I'm going to have lots of red boats that are good. And so I don't want you to consider that information. I'm going to narrow you down to the picture of the fish to make sure that's all you're considering. So if you imagine if you have like an adjudication system or something that's looking at an individual and their characteristics, there may be certain things about that individual you don't want the system deciding on, whether it's gender or race or other aspects. You want to make sure when the system says, I considered this information, you want to tell it, no, these bits of information are not what I want you to use. That may have been a historical aspect of some bias that was in the system of our people in some regard. We don't want that going forward. And so that kind of transparency is really important when implementing AI, when you have your governance policy to make sure that the AI can reflect back why it's made a decision.
Yeah, great. Amish?
I completely agree with Dominic. What I'd like to add is I look at governance as both design time and runtime governance. So at design time, I would apply the principles around which data sets are dependent variables, independent variables in my particular, if I'm doing a cognitive or a machine learning model, for example. And which one should I look at, which one should I shouldn't. So that's design time governance. At runtime governance, we could do policy enforcement depending upon where you are in the OSI stack. We could do governance around who uses it, how it's used, the certificate's been passed already. Again, depending upon, end of the day, it's the data. We need data. We need, for example, social data. It's orthogonal to the security requirement. Mm-hmm. So how do we bring in that social data, the nuggets from that social data, for example, and club to the internal data? Case in point being the Office of Trade example I was saying. So it is all about organizations out there that are dumping goods into this country, and all that data is in social data. Mm-hmm. But I need a mechanism, a governance mechanism, of getting that data in a very clean, streamlined fashion into and club it with my current knowledge, saying this company's applied for 20 times to come to this country, right? So that combination is both a design time and then in a runtime you apply it using policy enforcement techniques.
Yep, agreed. Bill?
The question highlights a key difference. There's Cloudera Customer Data Hub, which is the free distribution off the net. There's our Enterprise Distribution Hub. The difference between the two is the Enterprise Distribution Hub, which is a subscription annual one, comes complete with the security and the auditing and the management built in and maintained by the company. Again, for the purposes of this discussion, the importance of that is it highlights our philosophy that the technology should do many of these core attributes for you and thus free up the customer and their partners to be able to advance the mission of the agency, whatever it may be. Okay, so in other words, at Health and Human Services, and that's something we've done as a core function of the technology for quite some time. Just last year, in conjunction with Docker, we sealed 22 of the known security vulnerabilities in Docker, such that you can now use Docker boxes to transfer data from one entity, agency, to another agency, or from within agency. An example of that might be within Health and Human Services. If you want to transfer some subset of patient data and you want to make it time specific or the number of times it can be accessed, those types of things, you can use that technology. The discussion highlights, again, that the technology should be used as a foundation to advance the mission. Right. And that in our philosophy is that within government, that should be, that's table stakes. Yep. Right. Yep. And so that allows government customers, whether it's in the security realm or healthcare, banking, finance. Federal Reserve is a big customer. All of the predictive analytics are done by the Federal Reserve on Cloudera. all very secure data. So that just highlights how government needs that to operate in the public sector environment.
Absolutely. John?
Yeah, I'll add, we like to use the saying that you should be spending as much time thinking about the solution as you are developing it. And that means it's a multidisciplinary approach that you need to be taking. One of the examples that we often come across, just dealing with some robotic process automation, where do the security controls come from? Do we treat that robot as a human in an employee directory, or do we treat that robot as an application and apply security controls? That conversation just is sometimes mind-blowing for organizations to grapple with in terms of the policy implications of that. So make sure that you guys are bringing together folks from HR, from your technology shop, from other business lines to the table to have the conversation, because like I said, there's a lot of implications, that both positive and perhaps negative, that you have to be aware of.
Yep. And then just real briefly, Matt, you want to just finish this up and then we'll get into questions?
Yeah. I think the other panelists have more or less covered my thoughts. I just say that I divide it into two areas. One is, have you chosen data that's representative to the point where that data is training an algorithm that produces accurate results once you expose it to the actual population? Because if you use a skewed data set up front, you can expect bad results. And on a consumer level, think about highly publicized examples like photo recognition for consumer photo storage, and it appears not to have been exposed to enough minorities, and so when it's in the wild and it's exposed to minorities, it misclassifies them as possibly, in some cases, not even as people. That's not what you want. And given the stakes that government plays at, you can imagine even worse consequences, right? And then the other thing is that transparency aspect. So government needs to be able to explain why it's doing what it's doing, and it's not enough to just be able to say it came out of this black box and this black box is accurate. You do want that transparency, both to make sure that you're accurate and that you were using data that was representative, and also to be able to explain.
Yep, great. Thank you, gentlemen. So to questions, right here. Microphone coming, maybe? Yeah. Of course, it's completely opposite. I should have started over there. Right over here. Yeah.
Run back and forth.
Yeah.
From one side to the other.
I'll try to be a little more.
This is Sanjeev Pulapaka from REI Systems. So I had a question on unsupervised learning. So in terms of the panelist opinion, what's the proportion of use cases you see for unsupervised learning versus general AI use cases for supervised? And also, if you could mention some of those use cases, that would be great. Thank you.
So you're saying about a 60-40, supervised versus unsupervised learning, about 60-40 kind of mix at the moment. Again, depending upon which industry you're talking about. In government, that's the mix. In commercial, it's more unsupervised, because you have the ability to actually get different data sets, not so many rules and regulations. You can talk about IoT, other aspects. In government, 60-40 is the spend. But regarding unsupervised learning, I was talking about the social media example, wherein I'm not kind of holding any variables to ransom, saying, hey guys, you need to actually come through this model only works this way. So so social media is one use case that I can think of where the variables are completely independent. I don't know what's going to be posted. It could be a picture, it could be an image, it could be what on Twitter, for example, it could be text, a huge blog maybe, but in a tweet, like an image. So the ability to fix that, look at that, extract that, OCR it, for example, or read through it, and then provide content analytics on top. So that's a completely undefined, and so therein I need to be I could do some supervised learning, but again, I need to keep it open. That's one example I can think of unsupervised learning. Yeah. Answer your question? Okay.
Another one right here.
Yeah, this is Pankaj from Rizal. And we are incorporating AI into a couple of our solutions that we have developed for federal government. And I heard that you said we need to implement these solutions fast. But the challenge that we are running into is generating the model, creating the model, and it's a trial and error. And you have to go back and get new data, get that data, again run the algorithm, model might change. That process itself takes time. And getting that data from the government, from different data sources, that's just adds another challenge on top of that. So have you how do you deal with that kind of situation? Because now you're talking about implementing something in 3 weeks or 4 weeks, but I think it's just not possible until unless we use AI to implement AI.
So I can answer that. That's a good question, because I think what we're saying is the technologies are actually easy to pick up and deploy. And I think you've hit on well, how do I know if they're accurate and doing the job I want and that they have the right data that I need to effectively do the problem? And so what we try to tell people is you have to bake in this feedback loop process, because even the best AIs, they'll hit that 2% they don't understand, and we want them to raise their hand and say, I need more training data, or I need some help, or I need human oversight. And so the deployment process in that case includes this feedback loop to say, okay, we're going to deploy the model. We're going to start with having the model attempt to repeat what we did in the past. And so you might say, okay, I'm going to run it on last week's data and see if it can predict this week's data, for example. Oh, it doesn't seem to do that. Okay, well, what's different about the data? What's the feedback loop I'll use to tune and improve the model? But we want to get it out there and get it working on data so we get that feedback quickly so we can tune it and make it better.
Yeah, I think what we have seen is the first time we run the model, everyone is like super excited. This is just absolutely awesome. And then after that, like 3 or 4 iterations down,
The magic goes down.
the magic goes down. And then after that, you really have to figure out, okay, what exactly is the solution? And going to production, then that just adds another challenge. So I think it 3 weeks, I understand. I think if the model is developed, it's not difficult to move to production. But going through that process, I think that's quite iterative and trial and error.
Well, the training part, again, these are not coding systems, right? You need to train these systems. So the training part is an iterative process.
Yeah.
When I say we can do a pilot production, it's about, as you said, the feedback loop. The second thing which we are doing is for the customer experience, we implement things like traffic cops that actually, is like a big brother monitoring how much can a cognitive AI reply back with confidence. How many times is asking for feedback, how I answered your question. But then, if it's not answered, routing that particular this thing to a human intelligent, human call center agent, for example. But the customer experience remains the same. He's not moving and picking up the phone and calling somebody.
Yeah.
Somebody else comes onto a chat and responds back to it. So that's the slow way of actually implementing in a production system how we can augment. So we do, apart from the traditional AI piece, we also do this traffic copying kind of technology.
And we do need to wrap up. I apologize for stopping the conversation. It's a great dialogue. Hopefully, our panelists can have some other dialogue with some more questions if needed. I want to thank everybody for participating in this. Some people came from out of town in different areas. So thank you very much, and look forward to the rest.
Thanks all.
So we have about 5 minutes while they're going to be miking people up. So first off, emotionally prepare yourselves, because I'm going to be asking you questions again. So just get ready for it. So one of the things we want to talk about, so again, we see a lot of events, we see a lot of forums and discussions. I think today we've seen so many different angles and really a unique and diverse approach to these things. So what I want to talk about and maybe spend a little time is actually asking you, what are some of the key takeaways? Maybe something that surprised you, something that reinforced what you already thought. Maybe if you've got a call to action, if you've got something you want to think about on it. I mean, we've heard about the technical specs of it. I mean, we heard about everything from fraud to fraud and failure. It sounds like my dating life. Okay, people, you got to work with me here. And so all these different angles on it. So hopefully there was some surprises, maybe some things that you learned about it. Something I just want to introduce real quick. So when I first started going within GSA, hearing from federal agencies and being like, listen, we've really got to move forward and create government-wide programs about AI. There's somebody in front of you, there's one guy you have got to meet. This guy, Terry Rice. Not just because he owns a big green egg like I do, which is a fantastic cooking tool and the only plug I will give today, but also just because of his work through the Inspector General's office at HHS on this. And he was so instrumental in kind of shaping my thoughts on it. Terry, like, to get, and this is Terry over here. What's like a takeaway that you got from today, or maybe a challenge to the people in the room, as far as like what can we do moving forward on this? Other than updating the Emerging Technology Atlas on AI with these programs.
No, I think that's a good point. I mean,
Or do you just stand and
I can't wait to see that, even though it came out earlier than you wanted to. Getting into this early on and talking to the government about it, especially in my direct experience with HHSIT, they do a lot of analytics and they've been doing it for a while. Like I mentioned the ACL tool. Very scary.
Yeah.
But getting into the analytics of things, what I found, one thing that I think was a great takeaway was the mix of, thank you, the mix of industry and government and talking about use cases. And what I'd like to see is the development of case studies based on those use cases and what it actually takes to implement an organization that's going to do advanced analytics and use techniques like predictive modeling, or what we're calling artificial intelligence. I like the term augmented intelligence better, because we're never going to get rid of the human, and we shouldn't in that aspect. But what I found in a lot of my working with groups is they want to do predictive modeling. They want to understand that it's, the thing that happened. They want to understand why it happened, and they want to understand the likelihood of it happening again and what they're going to do about it. But what I find is when I go into these organizations, they don't have the resources to do it. They have some data scientists, or they have some engineers, or analysts, and what they really do is kind of database extracts and loads and transforms. They're not thinking about that modeling aspect, and they're not building an organization that can mature into that aspect of things. So I think taking some of these studies, especially from on aging at NIH, and what it took to actually get to that, or the waste, fraud, and abuse side, is that it's not replacing the organization that you have, but it's augmenting that organization with skills and the technology, but also the training and the resources to know how to do modeling and how to do those things. So I think that, again, some of the cases are awesome to listen to. If we could understand from a case study perspective how the organization matured into using these techniques would be awesome to see.
How many people agree with Terry on this? One, maybe three?
Three? That's awesome, 3 people.
All right, so are you already mic'd up already? See, that was very fast. That was still 5 minutes and it's already done. All right, so you've made it this far in it, and again, this is really, truly a special treat. Something that we at GSA get to see a lot of the times in the federal space, because again, this is such a critical mission to be able to bring the new ideas, voices, and businesses and demystify this terrible thing, which is the red tape and bureaucracy of providing solutions that will impact and improve the lives of the American people. Because all of us are in that battle together on how we can move around that space and actually get it done. So it's my great pleasure to bring up here our third final panel, the Next Generation Startup Showcase. Now these firms, they're new, they're trying to engage with government. That's the whole point of them being in this accelerator. So they're eager to meet you, they're eager to learn what you do, and they're eager to work with you on these things. And hopefully you'll also find the work that they do damn exciting. I know that I do. So please, if you could come up here. Officer of Decode to pick it up. Thank you so much.
Great. It's working. So we stand between you and lunch, and Justin had to mention a big green egg, so now you're extra hungry. But I promise this is going to be a really exciting panel, and hopefully you take away a lot from today's discussion. So a lot of what we're going to talk about really plays nicely off the previous discussion that we talked about. And really the idea today is let's see some actual emerging tech that's in the space and solving some really interesting and amazing problems. So you heard it from the panel, there is a lot of fantastic tools out there that can solve these problems that exist today. 3 of those tools are sitting here. And to the gentleman's question about use cases. So the technologies that we want to show you today are ones that have traction, they're making incredible progress, and really an opportunity for you to see that agencies are doing artificial intelligence, and these 3 solutions are ones that can give you some use case and examples of what they're doing. But more importantly, it really is very critical for everyone in this room, as you are starting to explore all the aspects of artificial intelligence, to know that it is real and it's here and you need to get out of the office and start exploring what emerging tech capabilities are out there. So just as an example, I know we talk about data scientists and what a valuable resource that is. All of the solutions here have some of the top data scientists in the world in their company themselves. So winners of the Kaggle competitions, for example. We actually, if you don't mind me saying, we have a unicorn on board, Dr. Evan Smith. She is an Arabic-speaking data scientist, so a bit of a unicorn. So she's going to talk about some of the challenges, especially with an IC perspective. And then just quickly on Decode. So we are an accelerator, as Justin mentioned, and we focus primarily on bringing emerging technologies to the federal government market, because we believe there's a lot of private sector technology that can work with a lot of the gentlemen that you saw in the previous panel to really bring significant change to the federal government market. So what we do is several times a year, we run a 3-month program where it's highly selective. We select some of the best technologies from across the country, and everything in the program is about how to work effectively with government. So it's de-risked for the companies, it's de-risked for yourself. So if you're a federal agency or you're a prime partner, I highly encourage you to get involved. For the federal government, there's no cost to get involved. It's really to see what emerging tech's out there and actually understand the capabilities that they can deliver. And why this is also important, we've been talking about innovation for as long as I can remember in the government, and I've been in the government probably 15 plus years now at this point. And this time it's different. So a lot of the gentlemen hit on this. I mean, before, innovation was improving the way that we did something existing. Now we're just fundamentally changing the way that humans operate, and we're augmenting the human capability to do things that we weren't able to actually do before. So it's a significant change, and the tools that are coming out of the emerging in the private sector have PhDs in deep learning neural nets. The skill set's changed. So I'm going to get off my soapbox for a little bit. We're going to have a little bit of fun today, but what we're going to start with is we're going to actually go down the line, and we're going to talk just 5-minute kind of flash pitches on what it is the companies actually do. They all play together extremely nicely. I think we'll cover everything from the data models you're running to supervised and unsupervised learning. And then we're going to flip back over. I'm going to have some questions for a panel discussion kind of around the challenges and how the agencies are actually doing and leveraging their tools. And then we'll open it up for the audience. And after that, you can eat. Sound good? Fantastic. So I'm going to start with Martin. He's from Kindy, if I said that correctly. I always mess up Kindy. It's probably because I always mess up my own name. So I'll start here, and then we'll just work our way down, and we'll just tell us a little bit about what you do, especially around artificial intelligence and how you're supporting the government.
Sure, absolutely. Well, good morning, everyone. Martin Rasser, Director of Analysis with Kindy. We're a San Mateo-based startup, San Mateo, California, but we also have a sizable presence here in DC, primarily focused on the government sector. In a nutshell, our products are focused on helping people discover knowledge faster and helping people anticipate future events. We do that with a set of patented technologies that are primarily our chief scientist has developed over the course of the past 15 years. Most of the use cases we have now are with DoD and the intelligence community, so several of us in the company have decades of experience in the Department of Defense and Central Intelligence Agency and the Defense Intelligence Agency. So far, we've focused primarily on proofs of concept with various agencies within those communities, and now we're at a point where we're focusing on product development to roll this out on a much larger scale. As I mentioned, we do have several patents in our portfolio, which was one of our investors' primary goals for us before we truly started rolling out, is that we protect the IP, since we do believe we have something truly unique and special. What we're very good at, we obviously do structured data, but we've developed some unique ways to deal with unstructured data, which presents a whole host of additional challenges, and particularly with the applications in Department of Defense and the IC that provides some grave value, and it's really a process of data discovery and knowledge discovery, particularly knowledge you probably didn't even know you had because it's so hard to wrangle that data. I can give you a use case. I can describe that later on to kind of give you a sense of the types of capabilities we bring to the table, but I'd love to turn it over to Evan so she can tell you a little bit about what she does.
Absolutely. So I'm Evan. As a data scientist, I'm thrilled to be here because our three companies represent the entire data science workflow. People will ask you what data science is. Data science is an algorithm. It's a means for exploration, for structuring your data, and for making predictions, and hopefully lending itself to actionable insights. And we kind of each represent a stage in that. So Martin talked a lot about discovery and unstructured data. The primary form of unstructured data is text data, which is what we at Thresher work with. And right now, we throw most of these data out. We simply don't analyze them. But there's a huge amount of insights to be contained within text data. And so what Thresher does is we help you build great training data through augmented intelligence. So a lot of panelists have talked about this before. This is the dirty secret of AI and machine learning, that we really don't have enough training data. So what is training data? The Google cat detector is a great example. I showed a bunch of pictures of things labeled cat and not cat, and it learns how to predict if a new image is a cat. With text data, this is really challenging, right? How do you create annotated corpora of text data? Right now, there are two ways. Your analysts read all of it, which is not great, or we outsource it, usually to places like Mechanical Turk or Crowdflower. And the need is obvious because all these companies are springing up. And this works for a lot of cases, but there are many cases that are really relevant to government, and particularly in the national security space where this isn't possible. You don't have enough analysts with the linguistic skills to read everything. And for security reasons, for proprietary reasons, you can't outsource that data, right? Maybe it contains personally identifiable information. Maybe it is secure in some other way. And so what Thresher does is we provide a machine-augmented means to developing queries that can label thousands of text documents in minutes, and then we structure that data for you so that you can move it down the data science pipeline and begin to run your models and really get actionable insights. And this is where Aaron picks us up in our workflow.
You guys hear me? Let's see, I'll hold this instead. So I'm with Data Robot. I'm running the federal team here within our company. We're based in McLean, Virginia. Our headquarters is in Boston, Massachusetts. How many of you guys are familiar with the movie Moneyball? Heck yeah. Heck yeah, right? So the Nationals, as an example, this afternoon when they beat the Cubs, are an example of don't laugh. It's true. Right. Predictive analytics. That's what we do. So our company is focused in on building out the best predictive model with your data set that you have. So Moneyball is an example of a person who used our software and uses our capabilities in order to help build out the best predictive model. And to Evan's point, after you have that data prepared and have the data ready, a lot of agencies, a lot of corporations sit there and they're like, well, I take months and months and months with data scientists who are better served at actually looking and making these predictions and making these insights. They're taking so long to actually develop the actual models. So our company was formed in 2012. We spent the first $60 million just on developing out basically a repository of the leading models, algorithms in the world, so that you have the ability now, when your data is prepared, to run it through our software platform. And what happens is similar, if you're familiar with the Kaggle Competition, which is the leading competition for data scientists, of which we have 160 of our 230 employees, and I'm not one of them. But we have those folks who are building out this software so that when your data set is run through, we essentially run a competition so that your data set, once it's prepared, comes into our platform and is able to run through the model, and a leaderboard is presented so that instead of a data scientist, if you know R and you know Python and I know TensorFlow, instead of us taking 7 months or 8 months or 4 months or whatever it is to develop a single model for that data set, our platform was built, and we took the first 3 years and the first $60 million, and we built out this platform where there's this repository of hundreds of open source models, plus any of those that you've developed on your own. I have many agencies who are like, I love my model. I said, great. Put it into the repository, and when your data set runs against our particular software platform and the top leading models come out like a leaderboard, like a Kaggle competition, we want you to be able to predict the model that's best for your particular data set, right? So we're going to help you do that. And what we do, and when we do that, we bring it down, instead of taking weeks and months to develop and help you figure out the best model for your data set, we're able to help you understand within minutes what is the best model for your data set. So coming back to the Moneyball idea, player prediction right now, we're doing something in the playoffs and in the Major League Baseball upcoming. We're having predictions on what pitch from a pitcher is more likely to be hit by a particular batter. We also have the #1 data scientist in the world, Amanda Shears, who knew nothing about basketball, zero. She was doing cancer research for Data Robot when she stumbles upon this thing where she lives in the UK called March Madness. She had no idea what it was. Well, guess who won in 2015 March Madness worldwide? Amanda Shears did, because she took all of this data that had been prepared by using tools like this. She built out her data set, which takes a lot of time. Again, we're going to augment the data scientists. We're not in any way, shape, or form saying, get rid of them. We're taking that data set, and she ran it through, and she was able to determine who was most likely going to win March Madness that particular year. So she was featured on ESPN, and she's a hoot. So she's going to come into DC soon, so we'll hopefully have her maybe come and see some of you guys. So throwing it back to Megan, it's a little bit about Data Robot.
Yeah, so we've heard about the tool, but now I want to make it real. So we've talked about how you fit together inside the organizations. Aaron, I know even just for Data Robot, you're doing some amazing work with Citigroup and some very large corporations like Netflix. But what are you doing for government? And I know some of you cannot talk about what you're actually doing from an intelligence standpoint, but let's give a flavor of the types of use cases and the actual problems that you can start. And Evan, I want to start with you because the founding story is really interesting as well. So I'll kick it over to Evan.
Yeah, absolutely. So our origin story is our co-founder and my former colleague at Harvard, Professor Gary King, was trying to reverse engineer Chinese censorship of Chinese social media. And he was really focused on making sure he had the correct data up front, right? Because the data, we've heard about this from other panelists, it's the foundation of all subsequent analyses. If your data collection is bad, if your annotation is bad, all subsequent analyses will be equally bad. But the problem is that the Chinese netizens were using code words to try to avoid censors. So one example is the 2-character phrase, I field. It means absolutely nothing, but it's the same 2 characters as for freedom with a line added to each one. So this is an example of code words. And so Gary and his colleagues worked on developing an algorithm through augmented intelligence, so iterating machine learning models with experts to unearth these code words so that the data collection and annotation up front was good and foundational for subsequent analysis. Other use cases are, for example, we had a data scientist who was interested in building a model for individual readmission risk in hospitals. And in particular, they were interested in evaluating the importance of family and social support for readmission risk. Family and social support isn't a structured variable. That's not in like your nice CSV that you get. It's in doctor's notes and discharge summaries. And so the data scientist was able to iterate very, very quickly and in less than 15 minutes process over 50,000 documents and create a structured variable that represented whether that patient had family or social support.
And who has teenage kids? I wish you could probably use this to detect what they're actually saying and expand your data sets. But I think what's fascinating about it is it does change the actual answer, and the actual outcome when your data set includes things that you may not have considered previously because you're augmenting, again, kind of like the panel was just talking about the human brain. But let's move it a little bit up the path of the process here. So, we've got to get to the data. We've got to understand the signals in the data so we know what to even look at. So tell us about kind of the problems that you're working on, the use cases for Kidney.
Sure. A few months ago, an organization called the Global CO2 Initiative approached us to help them with a horizon scanning project. Global CO2 Initiative seeks ways to monetize the fact that there's excess carbon dioxide in our atmosphere. So they're looking for ways to extract CO2 and then build something useful with it. They're agnostic as far as why there's so much CO2 in the atmosphere, so we'll put that debate aside. But basically, they came to us with a small data set of scientific papers that were presented at a conference. They thought these were very interesting. They were intrigued by them, and they were looking for investment opportunities. So they asked us, find us more research like this anywhere, doesn't matter where. So we took that data set, ran it through our software, and we can pick out signals such as technology maturity, level of innovation, idea density, concepts like that. So we then took those signals, showed them the results, and say, okay, well, here's how they map out. Which ones specifically are you more interested in now? They zeroed in on a few clusters. We took that information and did a prospective search online. We do that by breaking down all the text into mathematical graphs. Prospective search works, unlike Google, where you have to do keyword searches. You just find other mathematical graphs out there online that match, and then you bring in only those pieces of information, for the most part scientific papers, that match those graphs, and then we ran those through the software again, and again did a visualization of all the specific signals, the outputs that they were interested in. Zeroed in on a few more clusters and did the whole process again. Ultimately, we presented them with 20 scientific papers that exactly matched what they were looking for. Then they took that and went out and started doing their due diligence for investments. The point being, if a team of human subject matter experts had to do that same process, it would have taken many, many months. And in so many instances where there's money to be made, time is of the essence, and we were able to cut down that initial part of their workflow dramatically, and then the human beings, the human analysts, are augmented to go out and focus their efforts on finding that most promising area for investment.
Yeah.
So.
To jump in here, I think this is something that all three of us very strongly believe in, which is that no one is trying to replace the expert, but we have limited experts and we need to optimize their time. So I think what we all three try to do is take the best of what machines can do, which is process huge amounts of data, recognize patterns and anomaly, and pair that with what the best of humans can do, which is bring expertise, understand context, makes nuanced decisions in kind of hard decision environments, and try to do that in a way that is as optimal as possible with our experts' time.
Yeah, and Aaron, to kind of add on to what Aaron's saying, so now we've augmented the human expertise to find signals and data, prepare the training data sets. Now let's talk about some of the use cases, and we've heard some of them from Moneyball and across the board, but inside the government in particular, ranging from Homeland Security use cases to insider threat. Can you talk a little bit about the problems you're solving?
Right. So it's always interesting. People always ask, like, where do you focus in the government space? And because we're very use case agnostic, if you will, as long as your data is prepared and it comes into our platform in a structured, and I don't mean structured in the sense that we don't take unstructured data, we do, but we need a single file format. Our best examples are right now within the intelligence community. Our federal practice only got stood up really in November. We are extraordinarily busy. We're a small team, but I would say in the intelligence community, we probably have some of the most exciting ones that we can't always talk about, but here's a couple that are kind of interesting and kind of fun. One of them that will be kicking off actually with Booz Allen, they're our prime in this example, will be working with some unclassified data, and just based on something one of our banks did, they wanted to understand in their IT shop what network outages they could possibly be seeing coming up. Okay, so what they did was they used all of their Splunk log data, and who doesn't have petabytes of that? They built out a single structure, an example of their past power outages, their network outages, and they ran it through Data Robot, and within about 9 minutes, we could tell them, here are the ones that are going to be failing soon and on the day and the week and all that, so you could make that assumption. The next one that's probably pretty fascinating was a social unrest. Think Benghazi, but in an unclassified sense. But here's an agency that's like, where could it next happen? Everybody wants to know where could potentially something like that happen. So they gave us the work that they've been doing. It had taken them 7 months and 4 PhD brilliant people to build out this data set. They sent it over to us, unclassified data again. Our data scientists got it, and they were just going to run it through our software. Now, we normally just sell our software and you use it inside your own environment or you put it into the cloud. But in this example, they wanted us to do just a really quick proof of concept. So they sent it over literally through email. Our data scientists, within 9 minutes, came back and said, this is probably one of the weakest data sets. So they went ahead and added in a column of New York Times sentiment analysis. They added in a column of Twitter feed from that particular area of the region that they were looking at. They sent it back that afternoon saying, here's what we found for you. And it took us all in about, an hour total after we built in the pieces on New York Times and Twitter. So that was a social unrest example. To the point about hospital readmissions, we have a really interesting use case, which is Medicare and Medicaid, they're just not going to pay the hospital if a patient is readmitted within a 30-day window without extraordinary efforts going through to help understand, why did you have this person readmitted? So we took a data set again. We're going to take that historical data that you already have. So we took 10,000 patients. Somebody flagged one column of it, readmitted. Yes or no, within 30 days. And out of 10,000 patients, after we did our exploratory data analysis, which took about 2 minutes, we realized about 2,900 people at that particular hospital had come back within 30 days. So we ran the model and we were able to generate for them an exact report down to the reason codes as to why that individual patient was very likely to come back into the hospital, so that they could then use that model against all of their future admissions to the hospital. So when you have somebody, and it's very manual right now, and you had this hospital that had a person who had 13 emergency room visits and had 4 inpatient stays within a 30-day window. So able to help patient care, that patient didn't want to come back 13 times. It turns out in that example, it was a 76-year-old who lived alone and didn't know any better and just had a fever and went back to the ER, and then 3 days later had something else go on. But if we can improve patient care, that's fantastic for our patients. That's great for us because we all, at some point in time, go to the hospital. But then at the same time, the hospitals are seeing a massive cost savings and reduction in not only, how much they're losing out, but at the same time in turning beds and things like that. So that's an example of something really kind of in the healthcare space. We have a tremendous amount of interest right now, and we're doing some stuff on cyber, being able to help identify insider threat, who inside of your organization based on their past behaviors. If you look at the past, X amount of thousands of people who might have had a questionable SF-86 for the government, right, when they were trying to apply for their security clearance. I mean, how many of us have a security clearance, and how long did it take? If we could speed up that process on just looking at all of the SF-86 that were bad in the past, and then run that model against all the future SF-86s as they came in, that's another example of just helping look at it and just to improve some of the processes that the government's taking on day by day.
So this all sounds fantastic, right? Who doesn't want to solve these types of problems? But let's talk about where the rubber actually meets the road. So you're living it. You're working with agencies today. Let's talk a little bit about, especially for the government folks in the room, we heard about some of the challenges on the board. You guys have lived the pain. What does a government agency need to know before they start engaging with your tool to start, heading towards some of the outcomes that we've talked about today? And Evan, maybe I'll start with you.
Sure. So this echoes a sentiment that a commenter made earlier, which is the number one problem that we encounter is actually data access. Getting data prepared is often in siloed locations. We exist both on the public cloud and on the gov cloud, and so it's not a security issue. It's literally just a data transfer issue. And I think that a lot of times our clients just assume that that's going to be the easy part, and that it's going to be the tool implementation that's the hard part, when in fact it's the inverse. And so if our clients have put thought into how they're going to acquire the data, transfer it all to, say, one spot, from the very beginning of the project, everything else flows much quicker. Whereas if they come in just assuming that problem is going to be solved easily, we spend a lot of upfront time, and it delays kind of the tool implementation and the derivation of insight.
So Martin, how about from your perspective, because you're working with a lot of unstructured data, give a little thought on what you've run into and what groups should know before they start engaging.
Sure. There's two things. One, I'd want to emphasize that AI is not a silver bullet. It's definitely just one component of a comprehensive solution. So don't think that, oh, okay, now I have this AI thing and all my problems are solved. No, that's not it. Two, and several people have mentioned this today, the AI should be explainable. You need to understand how, why you got the answer that you did, because if you don't, you won't have confidence in that output, and think about all the use cases that we would have, be it in national security or finance or healthcare. If you don't have confidence in the output, then the tool as a whole has no value. So those are two things that you should think about well in advance before you even start talking to potential vendors and solution providers for those types of technologies.
I agree with that. I think for us, we realize that, and we know this, that if there is no executive sponsor, you're just probably not going to go very far. You could have the best data scientists in the world, but if the executive doesn't really grapple and understand what it is or what it even means, you probably right there have a problem. And so for us, again, I started this practice after, I think he's left, but after I was the first person pretty much over at Cloudera, and I spent 5 years at Cloudera. I had to go around and explain what Hadoop was. Well, now you come into this, and everybody knows what artificial intelligence is, and machine learning, and data science. Go around and ask one person to define it, and you'll never get the same answer, because it's just a big mystery about exactly what is it, and how do you demystify it. So what we did was our CEO had created this sort of program. Again, we're a small company, we now have grown, but he created this program called Data Science for Executives. And it's not about why you should use Data Robot. It has nothing to do with that. It's just trying to demystify what is AI, what is data science, what is neural, what do we do that